from 0 to 2 pi. Y minus z. So this is my x, this is my y, this is my z. So we have to plug in everything. So y minus z, what is it? Sine t minus 2 square root of 2. Z minus x is 2 square root of 2 minus cosine t. And x minus y is cosine t minus sine t. Dot product with the tangent vector of this equation, which is going to give you minus sine t, cosine t, and 0. Any question? Any question regarding if you have no idea what we're doing here? Have completely zero idea of what we're doing here. We're simply taking the inner product between the vector field and the tangent vector of the curve. The tangent vector of the curve is given by 3 derivatives here. And then you need to replace x, y, z in the vector field by your parameter. You have one parameter, you just replace it by that parameter t. You have two parameters, u and v, and you still have to do the same. And then this is simply the integral from 0 to 2 pi. What do we have? I have minus sine square t plus 2 square root of 2 sine t. And then I have plus 2 square root of 2 cosine t minus cosine square t. And last component doesn't give me anything, dt. I have a minus sine square minus cosine square, then I'm happy. You have a minus 1 from 0 to 2 pi minus 1 plus 2 square root of 2 sine t plus 2 square root of 2 cosine t dt. You can break this into 3 single variable integrations. Integral with respect to sine t in 0 to 2 pi is going to be simply 0. Okay, you can still use the rule to compute it. And the integral of cosine t from 0 to 2 pi is still equal to 0. So the only non-zero part is going to be minus 1. That will give you a minus 2 pi as the circulation of this vector field along this particular curve. Okay. According to Stokes' theorem, immediately I know this guy is equal to the surface integral of the curve, the surface. So I know this is also equal to minus 2 pi. But when we come back on Wednesday's class, I want to set up the parametric equations for the surface, actually compute why that is exactly the case. So the plan for Wednesday is to finish this example and then talk about our very last topic for the divergence theorem. So next week, next Monday, we're going to have our last midterm, and on next Wednesday, I want to have a review session. However, I spent a lot of time and effort to have this study guide online. I highly suggest you to go over it when you review it. Okay? So the study guide has not include these last 3 sessions, so I will gradually monthly to include everything. So you can look at the study guide in chapter 15 to prepare your last midterm, and then